Okay. It looks like I like being able to do this from the computer because then I could start it and let it cook on YouTube before actually streaming. So it's really nice. Nice to have
Hmm.
everybody here already. So hello. Welcome to our um, not quite emergency broadcast on on events that have happened the last day, and then we have another M class flare in progress right now, which maybe we'll talk about at the end
Yeah,
because the stuff's still coming in. But the big
yep,
one we're going to talk about is the M8 CME. So that's kind of
yeah.
what we have. But first, we're going to go over what happened last week because we've had a lot of stuff go on. So we're going to talk about the Coronal Hole and then this. I think that's our order of operations anyway.
Yeah, I think so. Well, let's actually start this.
Okay, yeah, started.
So I'm gonna share the slides. Eee. We're finally not sleep deprived or jet
Right,
lagged, so
kind of.
but I think that might, well, no, with the clouds it's not coming.
Yeah. Well, oh
So,
yeah, we'll get into that too.
yeah, we will. But we got a few active players on the disc, and even though the kind of the players that are ominously parading across the visible disk are all in the southern hemisphere with higher flare probabilities. It's really this region that is a lot smaller compared to the regions down south that's been doing most of the work. And
Yes, it's crazy.
this one is a storm producer. It gave us the storm in November. It actually was, I think this is third rotation of that active region across the disk. So it survived quite a few, and it was flaring on the other side, and now it's flaring on this side and producing some storms. So that will be interesting. We have a coronal hole that is rotating away, and that gave us the G3 earlier, well, last week, this week. I'm confused on this one.
Yeah,
And
technically last week.
yeah, well, technically, yes, it's Sunday. And we have one that's rotating in right now that's probably still going to be impactful because it's fairly low latitude. It's not passing the equator, so it's not going to be as strong as the one that we just saw, but we still see something out of it. All right, so
Okay.
yeah, recent events.
Yeah, this was
That was Yeah, it was a bit of surprise actually. So there was an X flare that preceded that coronal hole from like moving into geoeffective position. And there was a debate whether or not there is really a CME influence or not, but I don't think there is a reliable way to say for sure. But it did produce a very nice storm and very nice aurora that managed to beat the full moon, at least for some locations in Europe. By the time it rotated to North America, it was kind of too late, and we didn't get much out of it. There was some aurora, but probably, I think what I saw, it was limited to the northern regions, and it
yeah.
didn't.
There was some decent stuff on the Ely, Minnesota camera, but it was basically a green band,
Yeah,
so it wasn't like
very, very, very bleached.
yeah. But
The
that's
moon was not
that's all
kind
I
to it.
remember seeing from it
Yeah,
anyway.
nope, that's pretty much all we got out of it. So this is what happened. So it was one big mess. We had a change in a solar sector. So initial BX was in the negative, which is actually positive. Um, Solar sector, solar polarity, magnetic polarity. And then it moved into positives, but that's negative sector.
Mm.
So that happened. We probably saw a couple of very, very small transients, very short transient. This is the one that had a sustained negative BZ for some time. There is probably something happening here,
Yeah,
and there might be something happening here too. I just mark things very arbitrarily, but it's not unusual for the fast solar wind, as it's moving through, kind of trap very small flux ropes, so mini CMEs, baby CMEs. They get compressed, and because they have a consistent BZ in them, that BZ, when it's compressed, increases the total strength, and that BZ is going to be consistent. So it's going to be a fairly good driver of geomagnetic activity, which is exactly what we saw. We saw periods of G3 out of it and very nice aurora. Um, but, well, that was fun. But that's not unusual. Whether or not there was CME tossed in, well, we can talk about that too. But
Yep.
this is a coronal hole that really managed to be a very good storm producer for us. So this is the previous rotation. As you can see, it had a very nice compressed field. So magnetic field was fairly strong. It was pushing like 20 at times. And it had a sustained period of very strong negative BZ. So that was another storm. And you can see that's basically substorms. And all of that happened before solar wind speed really picked up. So that's that compression region of CIR. Um, and then it moved into sort of fast, typical fast solar wind. And well, there was one decent storm out of it, which correlated with the negative BZ, but that's that was pretty much it. So this is its rotation as of December. So it retained and actually expanded it transequatorial portion. So this was a lot more narrow on the previous rotation. Now it's expanded. And the speed was, well, slightly slower on this rotation. However, well, it had quite a few different things inside it. So those are very, very small active regions inside this coronal hole, and it's going to matter later. But it also had a period of very compressed magnetic field with a nice negative BC, and it definitely resulted in very nice substorms. So whether or not there was additional CME influence is really hard to call. You could argue that when BT is pushing 20, there's probably additional influence compared to its previous rotation.
Right.
Did we see a CME core out of it? It was forecasted to be a glancing blow, and again, that X flare actually happened all the way. Well, wait a minute, all the way over here. So there was very slim chance that we're going to see anything of that CME. So glancing blow was, I think, a very optimistic forecast. So chances are all of it was coming from the coronal hole itself. Maybe a little bit of help, but those periods of negative BC, strong negative BC that drove the storming, they are probably all coronal hole itself, with very small tossed in baby CMEs, potentially from regions that are very close to coronal hole or from the inside of the coronal hole itself if they're a little faster than the solar wind. So it's impossible to tell, but I don't think the X flare really contributed that much. It was there, it might have helped, but by mostly compressing the field, but no, we did not see the main portion of that CME. At least that's kind of my assessment.
Yeah, it's. I agree. Because it was so far to the east, but like you said,
Yeah.
it could compress things and
Yeah.
drive it a little bit further.
Hmm.
But
Yep.
yeah, so our friend the Coronal Hole.
Our friend Coronal Hole, unfortunately, is undergoing evolution.
It
So,
is.
over the last day, this active region very rapidly emerged inside the coronal hole and kind of trying to eat it alive, so to speak.
Mm-hmm.
So we might see smaller size of the coronal hole on the next rotation, potentially less of an impact, but that is yet to be seen. To what degree that this is a sizable coronal hole, so it's not going to give up its fight. And if you have a vacation planned in an area where it's higher latitude, so more northern location for the northern hemisphere and southern location for the southern hemisphere, chances are you're still going to see something out of it. I don't think that coronal hole will disappear completely. It might be smaller in the timing of arrival, maybe pushed toward the later part of the window. But if you have something planned for Christmas, I would say you might be in luck, particularly for the areas that do not care if there is full moon or no moon. Um, Basically, think about locations under Aurora Oval proper. It will be fun. But yeah, this is fairly typical for surge. Coronal holes are in jeopardy, particularly if they are transequatorial, because we start to see all sorts of craziness from active regions that are actively emerging.
Would you would you say it's cannibalizing it?
No, let's not mention those words.
Sorry, I
It's
couldn't help myself.
occupying, I know, it's occupying the space. So it's kind of pushing the coronal hole out a little bit. But no, it's not cannibalizing it. Sorry. All right. And this is completely normal for, again, for the surge. Coronal holes can get smaller because active regions are kind of pushing them out. They will be back. So once the surge kind of goes down, and the predicted time of the surge is actually December, once the surge declines, we're going to see fewer active regions. We're going to start to see coronal holes expanding in size and kind of popping up again. So we're not waving goodbye to this coronal hole completely. It might still be back, but it's probably going to change in size. And once we're done with surge and all the activity on the sun, we're going to see coronal holes back. We're not done yet with them yet. All right.
Huh.
So,
So yeah, flares and
Mary
CMEs.
Beth, you want to take this one?
Sure. Um. Oh yeah. Well, it's funny because people in the chat are talking about the airplane incident, which we can get into that a little bit later.
Oh, the Airbus?
The recall basically to
Oh,
yeah.
I would be delighted to cover that story.
Yeah. So we'll get into it, but yeah, it's definitely it's nice that they're. Well, I'll put it this way: it's nice that they're assessing it, but I think that was more cosmic rays and not solar related because there wasn't anything going on
Yeah.
at the time. But
No, definitely not.
solar
But
radiation is
let's,
radiation, so
yeah. Well, let's cover this part, but
yes,
we will come back to the Airbus story.
yes. So
'Cause
anyway,
it's
so flares and CME. So yeah, these two were pretty much on the heels of each other. They're real close together.
mhm.
M1 was the first one. It was eruptive, with the CME with a north northeast bias, and then followed by the bigger M8 with the more eastern bias. And I actually have a couple videos, um, which I could show you. So the flares. Actually, I let this video go. I mean, if you, I let it go a little longer because there's something cool that happened in the eastern side at the end there. That was neat. So I left it in there. But you see, it's like one, two. They're right next to each other, and then the video below it
Yep.
is with the over with the sunspot overlay, just because it's kind of cool to look at the sunspots.
Ooh, nice.
So, so it
Very
was
energetic flare.
yeah, very energetic, and obviously we got some CMEs out of it. So that's where, it's just funny because it's the after all the hype on social media comparing that one to the Carrington spot and all this crap, and then it's this guy. It's this one.
Yep, small one.
So now we can get into this modeling because
Oh, yeah,
it's
that's my
yep,
favorite field.
it's her
So,
specialty.
yeah, we are really kind of getting a bit of a CMS in this one. Well, first of all, the M2M NASA Moon to Mars forecasting office looked at the CME, and they basically the speed was measured as pretty fast, not the fastest we have seen, but it's still on the faster side. And estimated time of arrival is early December 9th. So, ah, didn't catch all the typos, but it is a very late, technically very late December 8th, because it's 7 hours on, well, more like 10 hours on either side, into midday of December 9th. So for North America, we're looking at arrival at some point Monday night into Tuesday morning. SWPC also modeled it, and it was fairly remarkable agreement. So we're talking about early December 9th. Again, those times are for initial shock arrival. So that means sort of CME touchdown at L1. And it does have fairly wide window still because and we will definitely cover this one because the uncertainty in timing of arrival is even higher compared to sort of the average baseline when CME is traveling through just undisturbed solar wind. This is Dr. Tamitha Scope's CME animation, at least one frame when the CME is traveling. So CME, the way it was launched, it's Solar Slinky, and it is sort of a slinky that's laying horizontally with a very, very slight tilt. And it is propagating, so it's moving our way with the legs of CME still attached to the sun. So it's not exactly blob of plasma that's just launched. It retains its connection to the sun throughout the entire time. And it just expands in space. So it travels across, and as it traveling, it sort of expands to the sides, and it also expands in its bulk. And
Tanya, sorry to
the
interrupt, but I did add
Yeah.
two other additional frames. You may have to reset
Ooh,
your slideshow, but of the top-down view
cool.
and face-on views from that.
So is it the next one? Next slide?
Yeah, they should be there, but I also edited the text, so I don't think your slideshow's updated. So you might have to go out and go back in.
Okay, well, let's do that. I'm going
Do
to
that.
stop sharing for the time being, and
Yeah.
whoever wants to cover this slinky and the way they travel and why that matters.
Well, no, well, it's cool to see this animation, or well, this visualization, because it really shows you how much it expands, and also having a visual on that slinky.
Yep.
Because me being a visual person, this makes it easier to see, and then having it in the 3D space.
Yeah, they're 3D structures.
Yes.
All CMEs are 3D structures. And the thing is, those slinkies, they definitely expand. They're also very flexible, so it's not a rigid structure. It can tilt, it can bend, it can fold a little bit. Those magnetic lines and that's how they're marked.
Mm.
They definitely can move around. They don't like being bent, so they're going to try to fix that. But otherwise, yeah, you can twist them, you can turn them a little bit. And when slinkies are coming in facing this way, when you think about it, that can start with either um, magnetic field pointing
North.
up, so
Yep.
north, or pointing down, which is south. As it passes through, it sort of becomes more flat, so it crosses a zero. And then on the other side, you have it either facing down, so south, or facing up north. So usually those types of slinkies that are very close to horizontal line, maybe have a very, very slight tilt, they do have a transition in the CME core itself that goes from either BZ north to BZ south by the end of the CME, or it starts as south and over time kind of rotates toward north. So they're bipolar CMEs, meaning they do change sign of the BZ, and that's not bad news for Aurora chasers.
Nope.
Assuming whatever region gets the CME part with a negative BZ, so remember this only applies to the core of the CME, we'll get to see Aurora. Where it's going to depend on how strong that negative BZ is going to be, and we don't know that ahead of time. What's interesting is CME also has a sheath, and I don't know if we have a slide with that. Yes, we
Yep.
do. So
Yep.
CME does have a sheath ahead of it. So that's the compressed solar wind. And we have a few CMEs that are in transit ahead of this fast CME. They're not included in the slide. So they could be trapped in that compressed area. And remember what happened with CIR when we actually saw a few compressed structures with straight just negative BZ for several hours? That can happen in a sheath too. They can be incredibly geoeffective. So you might get a little bit out of it as the sheath is moving through, even before you get to the core. The core is a little bit more predictable than the sheath. So again, you have to chase based on the BZ. Don't wait until the core arrives if BZ is favorable. Just basically grab your favorite app, Glendale, and go with it. Go chase Aurora. So that's
Anyway,
kind of cool.
I really like
So
those.
Yeah, no, those are fun because there are CMEs are very difficult to visualize when you're
Yeah.
looking at 2D structures when they're broken down into, okay, this is CME and this is CME. And this is actually CME too, looking down from the north into south pole of the sun. They're harder to visualize in 3D, and they're very much 3D structures. So this is a CME of the CME forecast from Met Office. And the reason I like it is they toss everything that's been tossed at us into that forecast. So we have one, and I think it's actually moving through right now. We have
Mm.
two, and then three, at least three separate things that could be potentially impacting Earth with different arrival times. So if we are somewhat lucky or unlucky, depending where you live, and you'll see one CME coming through, and as it's moving through, it's creating some favorable condition. What could be chasing it is the shock of that fast CME, creating the compression and also coming in potentially with favorable BZ. Then you're talking about really nice aurora. Of course, the opposite could be true. You can have CME and actually, I think that's what was going on earlier today, where we probably had a glancing blow of the CME with just straight BZ north for hours and hours and hours and hours. Will you see an aurora with that? Nope. Could it happen? Yes, it could. And then you're looking at maybe some aurora from the shock initially, and then we have to wait for the magnetosphere. If BZ is favorable, we have to wait for magnetosphere to actually load and produce aurora, or do absolutely nothing because the conditions are just not favorable. So we really do not know how things will play out from this one. We know something is coming. So, and Huck's is kind of telling the same thing. There are quite a few CMEs in the forecast, and all of them have fairly wide arrival time, so nothing is super spectacular because again, it's kind of difficult to model with so many things in the interplanetary space. You just get uncertainty amplified by another uncertainty. But the long story short, this is our forecast for Aurora. Big question mark. There are several CMEs with Earth-directed component that are sort of still traveling toward us with ETA within the next couple of days. We just added another one, but let's talk about it. Very high confidence in arrival. That M8 flare-related CME, it was so wide, I don't think it has a chance of missing us. I don't know what needs to happen to sort of create a U-turn and send it in a different direction. It may be more tilted than animation is showing because there was a CME ahead of it and slightly above it. So it might push it actually closer toward the ecliptic, which is favorable for us, but it may turn it just a little bit more and create less of the favorable BZ for us. But again, uncertainty in timing of arrival is even higher than usual. Usually, we don't have a good way to model the space through which CMEs travel. It's not a vacuum. There's a fair amount of traffic that could be in the way, and that's slow solar wind, different magnetic structures in slow solar wind. Now we have CMEs there. Slower CMEs tend to put brakes on the faster one. So it's really hard to model for that, and pinning down the time of arrival is going to be very difficult. And there's high uncertainty in impact. So we hope there will be some negative BZ in either sheath or the core. How much and when, we can't really predict. So can we say with certainty that G3 storming will happen? No. Absolutely not. And if you see any maps out there that tell you that this is aurora visibility, just run away.
Run
We have
away.
no good way of predicting it, and trying to really anchor on that prediction that you will see an aurora just because the map has been posted and we do have CME coming, that's actually pretty dangerous. That's a road to disappointment. Um, Again, we could see some nice magnetic structures in the sheath with favorable BZ. We could see all BZ north. We have to wait and see. So as usual, follow the solar wind data. It literally is L1 or bust.
That's that.
I think that's pretty much it.
Yeah,
Yep.
I mean, they put the G3 stuff out because again, that's for operational use. So it's
Absolutely.
always erring on the side of caution, and it does like some of the stuff does have a history of being rather potent when they hit, but you just can't always count on that. So that's the the word of caution because we have had disappointments too.
Plenty.
Plenty. So you
Plenty,
know.
plenty of disappointments.
So I guess now we could talk about what just
We
happened.
can, yeah, we can also, let, I probably should. Do you want to share Solar Demon? Do you have it up?
I don't have it up, but I can get it up. Let's see.
Okay.
Let me get rid of this and let's go to here. Yeah, this is the latest and greatest. What it ended up being an M2? A little bit over
M2.
M2. Yeah, so let's see. Let's see here. More. Show me. Okay, that looks like it. Alright, let me see if I can share this and not mess it up. So let's do this Windows. Let's see here. Okay. No, that looks like you're looking at my desktop, probably. So, let me drag it over. Okay, let's see. Oh no, where did you go? There we go. Okay. Alright, so this is Solar Demon. This tracks dimming.
We are seeing your email.
Oh god. How? How? Okay, I am not good at this at all.
Okay, well, let me do that.
Bring it up. Because, like,
Yay.
on my screen here, it shows that I'm sharing Solar Demon, so I don't know.
All right. Okay.
But obviously, you're watching it
Let's
live,
go.
so I
Yeah.
trust your judgment more than mine.
I'm watching Zoom, so yeah. All right. So let me share this.
Zoom
This
and
is
YouTube were seeing different things. I think we were the only ones seeing the email.
Okay,
oh
whatever.
boy.
Let's
Okay.
If that
do
helps.
this.
Okay. So this is Solar Demon. So it's automated detection of dimmings and flares. And this is the one that's well, when did it start? It started not that long ago, actually. Um, so this is our sun, and it is black and white and derotated to 11 angstrom wavelength. So it's the best for showing dimmings. Really, one of the best. But this is what's happening right now. So there was an earlier event, and if you can look over here, actually, you can see that that complex of sunspots actually produced something.
Yeah, something.
There is a little bit of a dimming going through. It's harder to detect, but if I roll it back and forth, you could see that some of the loops are opening and moving southwest. So we might see something from that, but given how faint it is, it probably happened at somewhere in high corona. So I'm not expecting that much out of it. And by location and direction, it's not going to be anything major for us, if anything. But we'll see. We'll see what the chronograph show. If you move, now we're moving further, and there is a flare, and it is eruptive. So you could see some plasma erupting from it.
Look how it twists. That's really
It
cool,
is
actually.
very twisty, and it's kind of going in different direction. And the wave of it is dislodging something else, so it's creating a wave, and there's some dimming. This is fun.
Yeah, that's actually a pretty cool one. So this
So
is the latest and greatest.
this is the latest and greatest. So we still need to see what it looks like in chronographs, whether or not plasma actually left, because sometimes it doesn't. It gets trapped, and then we're stuck with nothing.
Yeah. So okay, so now that we covered all that, I guess we can talk about the Boeing or not Boeing. I'm already blaming it.
Airbus.
I gotta take that back.
So I think
The Airbus story.
that's probably my personal take, but it was really a case of unfortunate miscommunication.
Yeah.
Because what happened, and now we know that there are several sources that are linking the incident and recall. So there was an incident where aircraft suddenly lost, what is it, 1,000 feet of altitude? So it almost dropped out of the sky. Not really. There was plenty of safe space underneath it, but it was very dramatic. It happened very quickly. And few passengers got injured. I think that was a JetBlue flight on October 30th. Um, Airbus investigated what actually happened and issued a recall saying that there is a software and probably hardware sensitive to intense solar radiation. That generated way too many questions from both sort of people who are following space weather and from space weather professionals because there was no major events. Sun was quiet, no major flares. When we looked at cosmic ray data, and there is a way to track that, that was fairly calm too. So that was not entirely clear what intense solar radiation Airbus was talking about. The official guidance for what needs to be changed in aircrafts was even worse because it talked about increased sensitivity or vulnerability to solar flares, which is not the case. All goes to it was a very high energy particle that literally zipped through electronics and caused a change in code that triggered the software to drop the plane. So the software that was installed on that Airbus 320 at the time was actually introduced in early 2024. It flew through Gannon storm. It flew through two pretty major solar radiation storms when we were just blasted by high energy particles, and nothing happened. And yet, that event where Airbus 320 just dropped for no good reason is still getting blamed on a high energy particle. Is that possible? Absolutely. Those particles are, fortunately, fairly rare. A lot of them are coming from outside of our solar system. So they're not necessarily generated by the sun. They're generated by things like supernova that are distant. They are crazy high energy. There is no way to shield anything from them. They're going to zip through just about everything. In semiconductors, they can flip a single number in the code. So machines and electronics actually communicate to the code is written in ones and zeros. We write it in words or commands, but it's translated into machine language through a chain of ones and zeros. And if one is flipped to a zero or zero is flipped to one, there is an error and the file could be corrupted and you could potentially have the program do something it's not intended to do. It's going to execute a very different command. Most avionics have, not just most, all avionics, meaning electronics on the aircrafts, they do have a protocol for monitoring for those events and correcting for them. So airplane could be blasted with tons of radiation, and yet the program safeguards those particle events, those single events, from affecting how the plane is actually flying. That can affect medical devices too. It's a known issue, and it's the same idea. You basically have an internal diagnostic running at all times to detect whether or not the device is functioning normally. So it's very rare that there is a vulnerability somewhere in the program that wasn't tested for. And it's really hard to test for all events. There was a case in 2017 when the device had a very unfortunate issue that contributed to patient's death. That's extremely rare. And in that case, 2 bits were flipped at the same time, which caused the device to malfunction. So that may have been the case with Airbus. And the idea in the correction was to revert the software to earlier version that did not have a couple of updates that were introduced in 2024 that may have been the culprit behind that drop in altitude. And Airbus is still working on the patch, so those same updates that were introduced in 2024, they're probably going to come back, but they're going to come back protected from those events happening. So, long story short, those particles are around us at all times. They are more common at higher altitudes. So if you're traveling, yes, something you can encounter a particle like that. But it really is all about being in the wrong place at the wrong time with a vulnerability in software and potentially hardware, and in the path of highly energetic particles. So that's that's really a very, very infrequent event. I think the one that preceded the most recent Airbus recall was happened in 2008. And again, there is a lot of mitigation in place already. And if anything happens, if anything is observed that's functioning out of the ordinary with that vulnerability to high energy particles, the airlines are reacting very swiftly. If that's discovered, it's going to be changed. That's why the recall was issued. Do I feel safe flying? Yes, absolutely.
Yeah. Long story short, there you go. There's actually, I remember, I don't know, reading or talking about this at one point because it does happen. There's been weird incidences where like even TVs or whatever just acted weird, because they were just hit by a random thing from outer space or some little particle.
Yep.
But yeah, they're not super common, but they happen. So it's good that they're on it. I mean, we could sit here and talk about radiation because, after I learned about how much radiation you get from just regularly flying at high altitudes, makes me, that's a whole different story though.
Well, honestly, nothing beats old-fashioned CT scan.
Yeah.
And any type of radiation you can be exposed to when you're flying, the dose will not be anywhere near high as some of the radiation you can get from medical procedures. To compare them, sometimes it's helpful to talk about background radiation. We all are exposed to background radiation, and that's coming from our sun. It's coming from, again, distant stars as cosmic rays. There's probably some coming from background, just basically, well, there's radioactive isotopes, radioactive materials all around us in their natural environment. That's normal. Everybody, whoever's tested for radon, it's a naturally occurring substance. Not substance, naturally occurring gas that's radioactive. It can be anywhere. So we get that exposure on a regular basis. If you want to think about flying, so I think I calculated once that flying from coast to coast is about 4-day equivalent of background radiation. And a chest CT will give you about 2 years equivalent of background radiation. So just to compare.
Fun times.
Mm-hmm.
Well, anyway, that's that. I guess, I don't know. I think there wasn't really any. Oh yeah, that's right. I was going to talk about weather.
Weather.
Let me let me see if I can actually share the screen properly. Well, there's solar.
This is tea, by the way, but I feel with the weather, I probably should be drinking something else.
All right. Well, you guys are probably everybody on Zoom is probably seeing something different, but I think on YouTube, people should be seeing the windy map. So I'm just going to roll with it. So let's see.
Confirming we do have your browser up, yes.
Okay, good. Because I'm going to bring up the cloud forecast for Tuesday. And, I mean, obviously our Southern Hemisphere folks are, you're in I could zoom over there if I want, but... So this is, North America on Tuesday, 9:12 p.m. Let's go on a little bit here. 9:04 p.m., 9 to 6 p.m. Yeah. I don't even have to really say much about this. It's not great. We have another storm system coming through, so basically everybody in the northern tier of the U.S. where you'd want to see, where you typically see Aurora is going to be under cloud cover, except for this little slit right here coming across eastern Montana into South Dakota. You might get some, or western Iowa, but the rest of us, we're going to be data chasing. We won't even be able to be webcam chasing. How sad is that? So, but if it ends up being really strong, maybe somebody down in California will see it. It's always clear. It's clear down there. So I don't know. That's my. I can't help but laugh because this is just crazy to me. It's like welcome to winter, where it's just permacloud all the time, no matter what. And you go into the next day. Let's see, because we have another one on the way probably, maybe. So let's go into like Wednesday. Still looking. I mean, it was a little bit better over in Minnesota, piece of the Minnesota, I guess, but and part of Michigan. So marginally better.
Yeah.
But this is rough. It's like, oh, ugh.
It's winter.
It's winter. This is what happens in winter. And I don't know if you noticed, we're in a La Nina pattern now. So therefore, we're supposed to have a wetter than usual winter, and so far that is tracking. And it's probably going to continue on, but we'll see. So anyway, that's the weather for your local meteorologist on cloud cover. I can't do it without a straight face because it's just sad. I'm like, oh, look at the whole northern tier of the U.S. Have fun chasing data. So
Yeah,
maybe
pick a camera somewhere else.
Yeah.
Or
maybe
I don't know.
Europe will be okay. Europe and South America, or not South America, Australia and Tasmania. Maybe you guys will have clear skies, and then you can report for us. You can take pictures for us. Maybe we'll travel virtually over there. But anyway, that's what I got for the day. So hopefully, do we have any more questions in the chat? I don't know if we do. They're probably all right. Let's see. I know I felt bad about. I'm not gonna just saying the wrong things. It's a good thing we don't have millions of viewers. I'll get chastised by Boeing for what I said. Whoops. All right. I think that's it for the day. Yeah, find a webcam in Australia. We're gonna have to. Yeah, Southern Utah might be okay. Yeah, if we get something good. I'm like, too bad I don't have a private jet. Just fly over to Utah.
If it's strong enough for Utah, we don't know that yet. So
We
the only
don't.
thing you really can do with this forecast is kind of put yourself in a position where you might be able to see Aurora and
Yeah, and hope for the best.
accept the chance that it's not going to be favorable because it's a CME. It's not like it's a coronal hole that's moving through where we know that it's going to drive something. This is really a big unknown.
Yep. So
So
terrestrial weather and all this fun. So. So anyway, I guess we could leave you all with that for the day. We'll probably be back next week with something, probably a forensics on this, because this should be this should be interesting to see. It's going to be complex. It's going to be hard to, well, maybe not super hard to follow, but we have multiple things happening, so we'll see how it actually transpires, and it makes for fun forensics. So, yay! But with that, we'll leave you be, and then we'll see you next week. We do have some fun things in the works for December and possibly January, so stay tuned on that.
yay.
Yay! All right, you guys have